All right. Welcome, everybody, to this webinar titled Event-Centric AI with Axon. If the headline is not fully clear at the start of this webinar, hopefully it will be by the end of it. So my name is Mark Lefter. I'm a Senior Solutions Architect at Axonic, and I basically help our clients to succeed in building event-sourced systems. And of course, since AI is all the rage right now, how AI fits into the event-sourced world is of much interest to users and clients everywhere. If you want to get in touch with me after the webinar, please do so, either via email or on LinkedIn. Both are valid options. About the agenda. So we will need to spend a little bit of time, and some of you might already, of course, be familiar with these topics that are CQRS and event sourcing. But a quick recap of these patterns is, I think, necessary because they underpin not only the systems that we build with Axon, but also sort of how they become the necessary ingredients in AI interaction. Next, we'll be looking at the Axon technology stack very briefly again and see what that enables us to do in this regard. And we'll try to visualize the sample architecture that our demo will be showcasing of combining the model context protocol and thus AI apps such as agents with Axon applications. And then onto some demos to see this all happening for real and ending with a Q&A and some thoughts about what lies ahead. If you want to ask questions, please do so. There is a Q&A button that you can click on and submit your question, and we'll get to those again at the very end. And also there will be a follow-up email where I'll share the repo and other links that might be of interest to you. So with that, let's get started. CQRS is a pattern that is quite simple, actually. It simply denotes a separation of concerns, one that has to deal with commands. And commands are a way for us in an application to change the state of the app. So by encapsulating an intent to change the state of the system in a command, we can send it to something or whatever we have in place that can process commands and thus impact the state and transition to another state. And then we have queries, the second concern that allows us to query the system after some state transition for relevant information, whatever that might be. So to visualize this a little bit, we might envision our system or application as divided into two clouds. One deals again with commands, one deals with queries fronted by some API or UI. And we typically refer to this separation as having both a command side and a read side on the left and right respectively. And we have different models in those clouds. We can term a command model versus read models, or sometimes we call them projections. And the command model, again, is where we try to impact the state of the system and change it when and if necessary. Whereas on the right-hand side, we can again query the system for interesting information. Now, what connects these two clouds together are events. So once we make a state change on the left-hand side in our command model, that produces an event or sometimes several, and we propagate those events over to the read side and update our projections that we can subsequently query. That's CQRS in a nutshell. But the commands and the queries, these terms, what they um, entail, will be of importance to us later in this discussion. Now, CQRS is a stepping stone towards what is sort of the meat of the matter, which is event sourcing. So a quick overview of that as well. Again, we have our command side and our query or read side. And we have, or could imagine we have separate databases, of course, for each side. And in the middle, we have this list of events that have been generated. Now, when we process a command, we get an event as a result. We append that event to a never-ending log, append-only log of events. And we can, of course, then stream these events to the query side and update, again, our projections in some data store that suits a particular need or purpose. Now, we call this event streaming typically, but what if we were to remove one database, the one on the command side, and instead use the event log as a database? Meaning we not only append the results of processing commands to an event log, we also use it, sort of source it back to ourselves whenever we need to make a decision about the next event when we process a command. So that's where the name sourcing or event sourcing comes from. We append events to this event log, but we also use it as a event store, taking the history of what has happened as a sort of truth or foundation for making new decisions. That is the next events to append. So you have event sourcing combined with event streaming, a very typical fashion. So that's was CQRS combined with event sourcing. That forms sort of the basis for what we might term event-centric AI. We'll see again what that entails shortly. Moving on. So given that we want to take advantage of these two patterns, we have a technology stack in Axon that natively supports them. And I'm going to focus on three core parts of this stack. First, we have Axon Server. Again, that's the event store where we store this append-only log of business facts that we have captured and persisted. But not only is it event storage, but it's also equipped with message routing. So when we send a command to our system and it needs to reach a destination, some command handler, Axon Server provides also the routing capabilities for that type of message, as well as queries. And as of version 2025, which was released a few weeks ago, we also have opened up Axon Server to basically any language or platform that supports HTTP or RSocket. So whereas previously you would typically choose the second part of the stack, Axon Framework, to build your event source system or application, you now have much greater flexibility in what language and platform you want to pursue that implementation on. But again, for if you're JVM based in any sense, you have a framework that is targeted specifically for CQRS and event sourcing application development. And to top it off, we also have a very nice observability suite for Axon applications. So we're gonna focus solely on Axon Server for the duration of this webinar. But again, if you're JVM based, you have a very nice option available in the Axon framework. So if we have CQRS and event sourcing as sort of a cornerstone in terms of patterns and that we want to employ, we have a tech stack that supports these patterns natively, what will an architecture that combines Axon with the model context protocol look like? Meaning, how will we be able to let AI applications access Axon applications for various in various scenarios? So model context protocol, as you probably are aware of, is a quite recent standard that aims to connect AI apps such as agents with external data. And the external data in our case is, well, very fundamentally, it's the event store where our events are stored. But we interact with the event store through, again, commands and queries. So while you can append and read events directly, and you, of course, consume events to build up your projections, commands and queries are there as sort of the interface, one layer above the events, you might say. We want to utilize commands and queries as much as possible, of course. So let's see how that could work together with MCP. I'm going to do this on the fly because it's always fun to do something in real time. So I'm going to switch over to Miro. And well, look there. I have a box that says agent. Always a good starting point. Now, agent, still hard pressed to come up with a single awesome definition of what an agent is. You will see that for the demo, I simply view it as a loop that interacts with an LLM with some tool calling, as it's called, intermixed. There are, of course, more fancy versions of agents out there, but at its very core, I think that's as good a definition of an agent as any out there. But again, we have something that wants to access external data. It wants to not only query what's in the event store, query our projections, but also trigger state changes. An agent might decide that it's time to, maybe by prompting from us as users, that it's time to change the state of an event-sourced app, an Axon app. So we must support that as well. And we'll have, again, MCP as the protocol for making this happen. And MCP consists of an agent, but it works hand in hand with an MCP client, of course. So when I prompt an LLM, or the agent prompts an LLM, it also includes tools that were discovered by the MCP client by invoking the MCP server. What tools do you have available for accessing external data and possibly making a function call to change the state of something? So we will have the ability to discover and call tools using MCP terminology. And we'll have to make a decision early on, at least to keep things simple, a decision on how comprehensive should this MCP server be. So if I provide a prompt to an LLM, along with the tools that a certain MCP server provides, what will be the nature of these tools, the functions that an LLM can decide the agent should call. Sometimes the LLM does the function calling or tool calling itself, but in our case, and I think it's more typical that the LLM makes a decision, this tool should be invoked, and that's what the MCP client will do on the agent's behalf. So to keep things simple again, and it's always a good starting point, we're going to keep our MCP server app specific. When I say app specific, I'm talking about the Axon app specificity. So I'm going to make an assumption that there is already an existing event-sourced app built with Axon, either using Axon framework, if you're in a JVM environment, or non-JVM options. So either an existing app built, again, either using Axon framework or these open APIs that were recently introduced in Axon Server. So you could build, again, I'm going to make an assumption that it exists, but you can start building it just after the webinar and hook it up to I'm going to call this app specific. and we'll see how that connects shortly. Now, you could endeavor to build a very generic MCP server, but that's quite an undertaking. If you build something that is specific to the app that you already have or will be building, some of the domain understanding that you already have can be sort of baked into the MCP server, and it's always a good starting point to sort of bring the domain knowledge you have, having built your Axon app, into the MCP server as well. So again, this will be tailored to the needs or the um, sort of the characteristics of the Axon app itself. So be aware of that. Now, this MCP server, something that will be running standalone, will connect to Axon server, our event store. We store our events and also provides these routing capabilities of commands and queries. And of course, this MCP server needs to convert all the messages. So the MCP server will accept a tool invocation from the agent and translate that into a suitable command if you want to change the state of the system, or a query if you desire to, yeah, retrieve some important information. Again, built up from the events that we stored in the event store. And the Axon server, again, knows how to route these messages. So they will be, again, routed via Axon server to our app. Make this a bit clearer, like so. So they pass through Axon server on their way, routed to our Axon app that is running. And again, if it's a command, we can just make it more colorful by using a blue sticky. Those of you who have done any type of command, event modeling will recognize these stickies. So an Axon application will have it, well, at least one, but typically several of these command handlers. Each one understands a particular command that it accepts as it has been routed to it. And we also, of course, have the query handlers for any queries that the Axon app receives. Like so. And again, so this is sort of the CQRS pattern in play. If you observe what we just perused about that. But we can, again, bring the final piece of the puzzle, the event, into play as well. So the command handler, again, produces an event. Let's make this a little bit smaller. And this event is consumed on the query side and updates some projection. And this is, again, what we deemed or termed to be an event that is streamed from the command side to the query side. And of course, this event, not only is it streamed, propagated from one side to the other, it's also appended, persisted in the event store. So there you have sort of the architecture that we want to achieve and understand and realize in the demo. So again, to recap, we have an existing Axon application or an Axon application to be built using one of the options that we have available to us. An Axon app will have command handlers and query handlers, and it can accept these commands and queries via Axon server. In our case, commands and queries will be sent to Axon server from an MCP server, tailored again to the characteristics of an existing Axon app, and the commands and queries have been translated into such via tool invocations occurring on the agent, with, of course, a lot of help from the LLM. So commands and queries are quite important, and they map nicely to tools, as you maybe can glean from this architecture diagram. And again, the primary means through which we normally interact with an event-sourced system and an Axon application, but they become even more, I would say, prominent in the MCP context. Okay, so let's see what is the best place to start here. Let's focus in on the MCP server. Now, you might imagine that even an app-specific MCP server is somewhat complex, but it turns out it doesn't have to be. So let's go into a little bit of code and see what that MCP server looks like. So again, I'm writing this in Python, showcasing the APIs that Axon Server offers us to operate in a non-JVM environment. So we create our MCP server here, and we define two tools, two functions that allows us to register a bike, because we're assuming we're working in the bike rental business domain, where we need to be able to register a bike. So this will actually mean that we need to change the state of a system that manages bikes by registering a new bike. And we do so by invoking Axon Server, sending a command to it. The way we send a command to it is by, again, translating this tool call into a command. And the command in question is this one. You can see that's a fully qualified class name that we have in our Java-based Axon app. And there's a payload, a bike identifier that must be unique. And we simply post that to Axon Server, and a command is sent and hopefully routed accordingly. And similarly, we have a tool that allows us to query the event-sourced app or system by getting all registered bikes. This URL looks a little bit different. There had some, think maybe a bug or something along those lines that couldn't resolve before this webinar. So I'm cheating a little by fronting Axon Server with a custom REST controller, just a detail. In normal circumstances, again, I would invoke Axon Server directly with, instead of a command, it would be a query to get all the registered or available bikes. Again, it turns into a command and or query eventually. But the MCP server in its simplest incarnation is simply this. Now, just to showcase I'm not hiding anything from you, I do have an Axon application that understands how to process or register by command and this query. And I have it here. So if you want to see what a command actually looks like, if I implement that in my Axon app, this is all there is to it. So I have a Java record, and that's all there is to this command, again, with some payload, the bike identifier. So this is the command message, if you will, that I can create in my MCP server and send to Axon Server, and it will be routed to some destination. And this destination is, without delving too much into details, a so-called aggregate. Think of it as an entity, if you're not familiar with the term aggregate, an entity in our business domain in bike rental. And here's our command handler, the one that understands how to take this command. And in our case, we simply apply, generate, append this bike registered event. Normally, you'll have some business logic as part of processing this command, but for now, let's keep it simple. So this is the command side where we process this command. And of course, we have the read side, the projection. And just to keep it simple as well, we consume the bike registered event and we update a projection, in this case, a simple in-memory one of bikes or bike identifiers. And whenever the LLM decides that, yes, this I want to invoke through this whole machinery, the get bikes query to get available bikes, this is where it will eventually end up, returning a list of bikes that we have registered. So in a very, again, simple use case that this is all there is to it. Again, this is the read or query side. So that's the Java app. We won't spend too much time on it, but I'll actually start it so that I have it running. Again, going back to the diagram, this is the Axon app that I just showed you. It needs to be available to have commands and queries routed to it. Now we have our MCP server. Now before we bring the LLM part of the puzzle into this, let's just make sure that our MCP server functions as we hope it does. And to that end, I'm gonna run a command that will allow me to inspect the MCP server, and using some fancy Python libraries, I can get to this view. Now I'm going to use, since I'm developing locally, I'm going to use just standard I/O to connect the MCP client with the MCP server. Normally this would be a HTTP streaming transport, but again, to keep it simple, I'm going to connect. So this now acts as an MCP client in lieu of what we will see shortly. But just to make sure that the MCP server is working, I'm going to connect to it. And I'm going to see what tools I have. So if I list the tools, I should see, yep, 2 tools and a description. And this is actually important. The more you can describe about your tools, either just through a simple string like we have now, maybe with a more structured schema, the better it is, because it gives the LLM an even more comprehensive understanding of what these tools are meant to accomplish. So register bike. Now, if I run this, and if I look at what the code did, it should register a new bike. And we should see this event being persisted in our event store as well. So I'm going to run this tool. And when you run the command, or you send the command, I should say, and it's processed, more often than not, you don't really get anything besides an acknowledgement that the command was processed successfully. And it seems to have been handled, processed and handled successfully. Now we should have an event as a result. If we go to Axon server directly and look at what it has persisted, what has been appended, we should be able to see that. So there's an Axon server dashboard. And if I go to search my event store, yes, there is a new event. And it's exactly the event I hoped it would be. Let's put that aside. So there's a bike register event, and there's only one because I've only added one thus far. So that tool seems to work when I just try it out. Also, I should be able to get the number of bikes that I have registered. So I should get exactly one bike identifier as a result. So that seems to work too. And again, if we inspect this, we can go to our queries. And we can see that, well, if you delve into this dashboard, you can see how many times this particular query was invoked. So I think I invoked this just before this webinar, but you can see that there's a query called get bikes. We have invoked it, and it did return what we expected it to return. So we have a way to not only change the state of the system by registering a new bike, we also have an ability to query the system via special projection. It gives us the list of all bikes. Terrific. So that means that our MCP server in its basic mode is functioning properly. Now, what is the next step? Well, the next step, again, if we look at our diagram here, is this part. How do we code this MCP client, or rather the agent, the loop that will interact with LLM and hopefully produce something that results in calls to the MCP server. Now, you'll be happy to know that the client isn't much more complex than the server, at least in this demo. Again, we're going to start a familiar conversation with the LLM, sort of in a loop. But to make this simpler, it's always good to have some, well, sometimes you want to really do things on your own from scratch, that's fine. But I'm particularly fond of a framework called Dapper Agents, which is quite recent, that enables you to build workflows or entire agentic systems that do offer hooks into LLMs where needed. So you can build deterministic workflows, but where certain steps are automated or do to interact with LLMs, to completely, I was about to say free-ranging agents that run amok now. But this Dapper Agents framework is quite interesting. Dapper itself, if you're not familiar with it, it's an open source project that basically defines a number of standard building blocks for interacting with common cloud native services such as state management, messaging, workflows. But Dapper Agents actually quite standalone, so you don't actually need to embrace all of Dapper to use it, which is quite nice. But again, I'm just using it to sort of use some agent abstraction to make things simpler. So using Dapper Agents, and I will link to this in a follow-up email as well, I start by, again, creating an MCP client, and I want to connect it to my server. This, again, uses standard I/O. This would be switched to a HTTP streaming transport in a real-world case. Once I've connected to my MCP server, I need to get all the tools that the MCP server exposes. And then I instantiate an agent that allows me to, let me showcase this, that again will simply wrap my interaction with the, in this case, OpenAI model. And I give it a suitable name, a role, and some instructions. So I tell it that, yeah, you should act as an assistant. You should understand that there's an inventory of bikes in my bike rental service. And you have some ability to, again, register bikes and getting the status or list of available bikes. So my system prompt, or call it instructions to the LLM, will be always contain this, along with the tools that I discovered. And then I'm gonna go into this loop and I'm gonna send a prompt, get something back, and then have this happening until I'm satisfied and done with my conversation. So again, in a simple instance like this, there's not much to your agent. Of course, this can be expanded in many various ways, but let's stick with this for now. So what does this look like when we run it? Well, I'm gonna run it here, and I'm gonna hook myself up to OpenAI as well. So here I'm using by the way, a library called Chainlet. So it gives me a nice UI with some bells and whistles that I'm too lazy to build myself. And yeah, so this is my chat interface. Let's see now. So I have my Axon server is up and running, my Axon app is up and running, my MCP server is up and running, and so is my client. So all pieces are operational. Let's start with asking it what kind of bike inventory operations do you support? And since we gave it enough information about it, it does understand that, yes, I have the ability to register new bikes. and also getting the bikes that have been registered. Okay, so register a new bike. The bike has been successfully registered into the inventory. So we can check it in two ways. Let's do it the old-fashioned way. Let's see what our event store now contains. If we have a second event, then it works, as we do now. All right, so we got a new bike because the identifier is different than the previous one. But, well, let's do another one, another bike. Okay. And we can also now see how many bikes we have. So give me the list of bikes. And hopefully we get, there's a little bit of a, not bug, but my app has, I think, no, there are actually three. Yeah, that makes extra sense. So yeah, it does return all the rest bikes that I did add. There was actually three of them. So there you go. We have an agent in the loop that understands the tools that we have offered it. And while it doesn't do the tool calling itself, it does determine what tool to call in various circumstances. And we have successfully both added something to our system. That is, we have changed the state. We've sent commands to our Axon app through Axon server. We are also able to query the results of registering new bikes. So in this way, we sort of have one source of truth, our events, this historical record, and that is that source of truth is something we interact with through this interface. And thus we have now completed the connectivity that we were looking for. So where do we go from here? Well, there is something that we have the slides here. We look at the agenda. One thing was, then where do we go from here? So one thing that was mentioned in the abstract of this webinar is how do we process events in real time? So we sort of do this already, right? So in our Axon app, whenever we register a new bike, we update our list of bikes, so that happens in real time, and our agent is then able to query it. So more or less, as soon as a bike is added, we can retrieve it. But real-time stream processing is not really that. Before I go into that, I want to just mention that we're not actually, again, retrieving events from the event store. We're just querying this Axon app. So when will we need to actually retrieve the raw material? And how would we do it? Well, we could add another tool that would actually get the events for a certain bike. Right now, we only have one event we have registered, but a bike becomes reserved and used, and you use it to ride for an hour or so, then you return it. All those events, those business events that relate to a bike, we might sometimes want to retrieve them either for a certain bike or for all bikes or a subset of them, and provide them as input, that sort of set of events to the LLM, and let it reason on a larger number of bikes. I haven't implemented it because there are a few ways to go about it. One way is to use what's called resources in MCP. There are none right now, but resources are basically a way to retrieve some results from a data store, like events from an event store. So we could retrieve them and then feed them into the LLM. And the difference between a tool and a resource is that a tool is the decision to call it is made by the LLM, whereas a resource is something that the AI app determines. It's not controlled by the model itself, though I think it can be in certain circumstances. But either way, you can retrieve just sort of the raw material, say for the event stream for a certain bike, and provide that to the LM to make its, well, to augment its reasoning, decision making. And resources also provide a way to, if there are new events, you can push them, stream them as they happen. So there is a way to sort of achieve that real-time aspect of stream processing, quote unquote, that way. But the clearest way to do it would be, again, to utilize those open APIs in Axon Server that were recently introduced. So basically, I would take this event and I would set up my own event handler. I'll call this event handler stream processing. And imagine now that you're working in the analytical space. So right now we think of ourselves an application team. We build an application, we build this app-specific MCP server, but we have a team that works in the data realm. They are data analysts, architects, business analysts. They don't really want to touch the app side of things, all of the other moving parts here. What they want is just access to the events. So what they can do, if they're Python savvy, is just like I did, code something worthwhile, an event handler, register that with Axon Server, and then start receiving events. Whatever happens next is fully up to them. They can propagate these events or transform them in push them to a data platform like MongoDB Atlas or some data lake. You can create your own projections just for analytical purposes. There's a whole host of scenarios that are made possible. Why not even create your very own MCP server or some other agent scenario that you envision? So you have now more freedom to operate, given that you can register your event handlers and process events directly in real time for whatever purposes you deem fit. And of course, you can combine MCP servers. So an MCP client and agent can connect on not only one, but several of these MCP servers. One thing that I've been focused on is providing a schema, a centralized schema. So right now, again, this MCP server is quite hardwired, which is okay for this app that I have in the bike rental domain. But if you're looking to go towards a more generic MCP server, perhaps, but also to document your domain, what are your commands, your queries, your events? You can, if you sort of extricate that concern from the MCP server, and maybe you want to utilize something like event catalog, something that's a very nice way to, again, schematize your domain, your events, commands, queries. You can let the LLM call that. So event catalog has its own MCP server, of course. So if you're working in the bike rental domain, you can instruct the LLM that, well, one of the tools is event catalog, specifically this bike rental domain. Fetch everything that you know about, well, that event catalog provides in terms of documentation, schema about that domain, and your LLM will do the rest, hopefully. So do look into event catalog. I've done that, and it's quite fascinating what you can do. But that sort of starts you on the path towards a more generic MCP server that has more reusability, but also the good point about it is you start to actually document your domain in a structured fashion. So yeah, that was the final scenario I wanted to touch on, stream processing. So hopefully you've gotten some sense of what event-centric AI, or at least in the event sourcing context, means. Both the ability to react to real-time updates, but also, of course, to get access to this historical record where the what or why something happened is very easily forgotten if you're not using event sourcing. And this is something that is, of course, of much interest to an LLM when it's supposed to reason for you. I'm going to make the code repo available to you shortly in a follow-up email. I'm just going to polish it a little bit and document it so you can run it yourselves. But with that, we have, I think, arrived at the very end of our webinar. So we have 15 minutes or so if there are any questions. But I thank you for your interest thus far. So let's see what questions you have about this. Let's see if I can get to them here. So we have MCP is cool, but what about custom chat GPT? There's open schema probably out. Yeah, there are many other moving parts that I haven't touched on here. Authentication or the security aspects, not the least. And also in terms of whether you should actually, as I mentioned, make events in your event store solely available to any agent out there or LLM that needs them. There can be some business critical information, of course, that you might not want to expose just directly by getting the raw events. They should sometimes or often be seen as an internal detail. So yeah, I would pay particular note to that. But again, some events also store, while not user information directly, you might have some of that encrypted. But yeah, be careful how you sort of expose your business events stored in your event store, and to whom. And I have not at all touched on authentication, authorization, all of that, but it's of course of prime concern as well. If you had event streams that you did not want the MCP client to be able to access, how would you implement? Yeah, you would control all of that in some manner in your MCP server. Something I'm still exploring what is the best way to do so, whether you implement it yourself or you use some third-party solution for it. That's to be determined. But in our case, we're already sort of shielding ourselves from what event streams we access. We don't access them directly, we do that indirectly. So when we send a query or have the LLM decide that a query should be issued, we're reaching out to our system, event source system, but not to the events directly. We're targeting a specific projection that we query. That projection has, of course, been updated by our events in the event store, but again, we're like one layer above the events when we touch the queries and the projections. So that is sort of a restriction in itself, but you can be more specific here about what queries you do allow or not. And if you're not accessing your event streams at all, well, there is simply no way to do it. So in this case, we're not allowing an MCP client access to the raw events at all. Hopefully that answered your question, David. Anything else that you had some thoughts about or wondering about? If not, again, I can be reached via, let's see, via email or LinkedIn. And while I'm not making any formal declarations about what Exonic will offer in this space, maybe this webinar gives you a little bit of hints about the direction. If you have any thoughts or proposals, or if you're working with Axon already or interested in looking more at Axon and how it sort of interplays with MCP and agents in general, again, please reach out. I'd love to have that conversation continuing. So yeah, with that, thank you very much.